Alright, this video is one of three. There are many ways you can go about doing stoichiometry, the math aspect of it. It is contingent that you have watched the other videos before you watched any of this three-part series. So to do stoichiometry, I currently know of three ways. There are probably a myriad of ways you can probably go about doing these. This is factor label method. And if you remember from baby chem, or whichever chem you've taken before this, factor label method is simply setting up conversions between one thing and another. So if you have a balanced equation, and here we have a fully balanced equation, you can set up your factor label method if you remember that in a balanced chemical equation, the coefficients in front of each compound in the balanced equation represent a ratio of one element to another, known as the mole to mole, one compound to another, known as the mole to mole ratio. So if I want to know how many moles of hydrofluoric acid are needed to fully react with 0.3 moles of sodium silicate, I'm looking for this over here. I start with writing out what I have. I have 0.3 moles of sodium silicate. I need to get to moles of hydrofluoric acid. In dimensional analysis, or factor label method, the unit that came before goes below. So down here is moles of sodium silicate. I hope if I got this right. It should be a lowercase I. Alright, that's better. So we look up at the balanced equation, and the coefficients are simply the numbers that go in this ratio of one element to another. So sodium silicate coefficient is 1, so 1 goes down here. Hydrofluoric acid coefficient is 8. So we pull up our calculator. First, that would help if I turned it on. And we type in 0.3 times 8 divided by 1, and we get 2.4. Minimize that. 2.4, three significant figures, so 2.40 moles of hydrofluoric acid would be how much you would need to fully react. Circle it so our grader knows what we're talking about. Alright, so we're going from mole to mole. That's the easy part. The harder part is if you have to go to a different unit. Now I've picked grams because that's the more complicated of the two. But realize that you could be asked to go to liters, and to use that if you're at standard temperature and pressure, whatever number of moles of product or whatever number of moles of your answer that you're looking for, you would multiply it by 22.4. Or if you're not at standard temperature and pressure, you would have to use the equation Herb inert, PV equals nRT. If you are lost on that, come and see me and we will go over that in greater detail. If you're asked to go to atoms or molecules, you use Avogadro's number 6.02 times 10 to the 23rd. Well, I'm choosing grams because grams is where people get a little lost sometimes. So we're just going to only do that one for these three videos. So how many grams of water? How many grams of water? I'm looking for this. Can be produced by the complete reaction of 0.8 grams of sodium silicate. So again, I have 0.8 grams of this, I need to figure out how many grams of water are going to be produced. Alright, unlike before when I started with moles, I can't just go through the mole-to-mole ratio. Before I can do that, I have to figure out how many moles of sodium silicate I have. So we set up another factor label or another dimensional analysis. 0.8 grams of sodium silicate Gotta figure out how many moles that is. And I'm just going to abbreviate this. Sodium S. Grams go below. After we figure out how many moles we have, we can figure out, I don't need that big of an arrow. After we figure out how many moles we have, we can figure out how many moles of water that would produce. And that's the mole-to-mole ratio again. And once we know how many moles of water, it's a simple hop, skip, and a jump to go from moles of water to grams of water. The largest unit gets a 1 in front of it, so the largest unit here between moles and grams, a mole is infinitely big. So that's going to win. Mole to mole, it's a tie, so no 1 is given. Grams to moles, again, mole is the biggest unit, so it gets a 1 in front of it. How many grams are in 1 mole? Well, we got to find the molar mass of sodium silicate. So in sodium silicate, I have 2 sodiums, I have 1 silicone, and I have 3 oxygens. If I add all those, the mass of all those up, that's the molar mass of sodium silicate. So if I look on my periodic table, I find that sodium, I believe it's 23, so let's do it right off periodic table, 22.99. I find that silicone is 28.09. And oxygen is 16. So again, I pull out my calculator, and we put in 2.99 plus 28.09 plus 3 times 16. Molar mass of sodium silicate is 122.07 grams per mole. Coefficients go in a mole-to-mole ratio, so there are 3 moles of water to 1 mole of sodium silicate. Molar mass of water. I have 2 hydrogens, 1 oxygen. Hydrogen is 1, oxygen is 16. 2 times 1 is 2, plus 16, 18 grams per mole. So again, I just pulled my calculator now, and I do 0.8 divided by, I'm just going to pull up what I just typed in. So that's how many moles of sodium silicate I have, times 3 divided by 1 gives me 0.019 times 18, because that's the molar mass of water. And I get 0.3538 0.3538 grams of water. I'm not done yet because my question had 3 significant figures. Here, I'll do it in the blue. three significant figures in that number, so I need this to three significant figure. 1, 2, 3. 8 pushes that 3 up. So my answer is actually, move this over again, 0.354 grams of water. Circle it so our grader knows what we're talking about, and we are done. So this was factor label method. If this does not work for you, watch one of the other videos and maybe it will work better.